So this is how we can create a constant string. There is one more way. We can just write star. Okay, ch like this in front of this. Okay, so this is like also a constant string. So if I'll like print printf, okay, percentage s, or if I'll write like percentage c comma chfi. So what I'm doing, I'm trying to like access the first character from this particular string. Okay, definitely we'll get a small j as output. Okay, now what I'll do, I'll just try to modify this. So what I'm doing, I'm starting ch of 0 is equal to and like t. Okay, t. So what I'm doing, I'm just trying to modify this string. Okay, and just a minute. But I'm trying to puts. Put as the function that is basically used to print a string. Fine. Let me compile this. Compile if I try to run this. Okay. So what is actually happening? We are getting the exception, right? Not exception. So your operation is illegal. So we cannot modify this type of string. It's actually a we can say a constant string, a constant array. Okay. So that is constant. You cannot modify it. If I try to modify it, look at this. We're able to modify it. But if it is like a simple array, okay, so it is modified. But if we'll put a star in front of this, now it is a kind of constant string. You cannot modify it. This is how we can create a constant string. So look at this. The operation is not allowed. So we are getting exception, and our program is terminating abnormally. That's why we are not getting the value of this put s. So this operation is not allowed. So this is actually a constant string. So we can have different type of constants. So integer constant, real constant, single character constant, and string constants. Fine. Now, let me move forward. Okay, after constant, we are having some special symbols. Exclamation mark, at the rate, these are the symbols that we can use in a different like section of our application. So these all symbols that can be found on keyboard are called special symbols. Every special symbol has a special meaning in different respect at the different places. That's why these are called special symbol. Okay. Now let me show you one thing. What are special symbol? Okay. So can you please tell me what is the advantage of this star? What is this? What is this operator? Can you please tell me?
You know, Mitra.
Please check it out. Can you please tell me what is this operator? What is the name of this operator? Anyone? It is a single pointer. Absolutely correct. Okay. Now what I'll do, if I'll printf, and here I'll specify percentage s, and if I'll write a star of ch. Okay. Can you please tell me what is the name of this operator at this particular line? Here it's a pointer, and at this point, name is changed now. Absolutely, it is indirection operator. Please turn off your video. I'm Saraswati. Please turn off your video.
సరస్వతి వీడియో ఆఫ్ చేయండి.
Okay, no worries. Fine. So this is how we can create a pointer variable This is a dereferencing operator, okay, or we can say the indirection operator or the value of address operator. Okay, but when we put this operator between two operands, now its name is changed. Now it is multiplication operator. Okay, so look at this. This operator have like different meaning in different section of a program. Here it is basically used to create a pointer variable. Here we are creating this star as an indirection operator or to retrieve like value associated with an address. And at this point, when we put this operator between two operand, it is a multiplication operator. So this operator have different meaning respect to different location. Okay, that's why it's a special type of operator. Okay. In the same way, we are having like a lot of operators. If we talk about this uh, AND operator, okay. This operator have different meanings. So you can use this operator to like retrieve the address associated with the variable. And second, it is also used for like a bitwise AND operation. This is bitwise AND operator. So this operator have different meaning in a different location of your application. So these are like the special operators. Yes. Okay. Now, special symbol operator, as you all know that these are some kind of special symbols that can perform arithmetic and logical operations. So machine can perform only two kind of operations. The first one is arithmetic and logical. Okay. So operator are special symbol that perform some kind of operation. And a more formal definition is these are the like behaviors, okay, that you can apply on different type of data. The purpose of operator is to convert data into information. Okay. So if you are having two variables in memory and you want to perform the summation of the two variables, you must require that plus operator. So if you don't have plus operator, you cannot perform addition. The data always remain data in memory. It will never get converted into information. Okay. So whenever a programming language provide you data type, along with the data type, language provides some operators that you can use to modify the data. Okay. So with the data types, we are having operators. And whenever you create your own data type, then it's your responsibility to create the operators. Okay. So when I will work with the object programming, then I'll show you how you can just create your custom operator according to your like data type. For example, whenever we create a class, a class is a data type. So we have to create its operator in form of member function, or we can say the methods. Okay. So operator are basically the symbols that are used to transform data into information. Okay. So see this rich in operator, we'll discuss operator in a greater detail. Okay. Fine. So can you please tell me how many operators we are having in this particular statement? Please check it out. Absolutely correct. Okay. Two operators. The first one is equal to, second one is plus. Okay. This semicolon is a delimiter. Okay. C, A, and B are the variables, or we can say these are the operands, and there are two operators. Now, in the example, plus and equal to are the operator that operate on operand A, B, and C. Right? So to convert data into information, we need operators. So operator is one of the most important part of any programming language. So whenever a programming language provides us like data type, along with the data type, it provides us a rich set of operators that are used to modify values associated with these data types. Okay. So let me show you a small example. We are having like integer. Okay. So integer is a data type. Okay. Now to perform operation on integer, so we are having like a lot of operators like plus, minus, divide, multiply, modulus. Along with that, we're having that less than, greater than, less than, equal to, greater than, equal to, not equal to operator. Okay. Along with that, we are having like a and or, okay. Along with that, bitwise operator, left shift, right shift. Okay. So these operator you can apply on any integer type variable. So whenever a language provides data type, it always provides a rich set of operators that are basically used to transform the value associated with the specific data type. Okay. So without operator, data always remain data. It will never get converted into information. Okay. So to transform data, we need operators. After that, just a minute. Now we are having some like character and string as well. So the character that can be used to form words, number, expressions, depend upon the computer on which the program is running. So the character in C are grouped into following categories. So we are having letters, digit, special characters, okay, like your star, ampersand, dollar, and all that things, and white spaces. Okay, these are non-printable characters, but these characters play an important role in a C program. So some of the white space characters are space. We are having tab, slash n, that is the new line, slash r, carriage return. Okay, like slash a, okay, audible bill. So these are different escape sequences, and these are non-printable characters. These characters have a specific functionality associated with it. Okay. So remember that whenever we specify a character in C, we have to wrap the value within single quotation. So A is a string, okay, character. And when we wrap this A in double quotation, it is a string, means it is a sequence of character. Okay, so there is a difference between these two characters. Okay, here it is a character and here it is a string. Okay. Now, the next important thing that we are going to discuss is data types. Okay, so can anyone tell me what is a data type all about?
Data type tells which type of data that variable can store.
Absolutely correct. Anything else?
Copper.
Yeah, Munawar, please. Okay, fine. Anyone else? You are absolutely correct. So what type of data? Okay. So C is a kind of a type language. Okay. So it means that whenever we create a variable or an expression, a variable and expression always have a type associated with it. Okay. So it is we can say a type language. So whenever we create a variable, we must have to associate a data type with that particular variable. And whenever there's an expression generated in memory, that expression always have a data type associated with it. Okay, and this data type help us in a type compatibility check. So whenever we try to assign an invalid value to a variable, our compiler show us a warning message, okay, that you are trying to assign a invalid value. So most of the problem are resolved at the compile time. So this is advantage actually. Okay, so we are having like different type of programming language. Some are loosely type and some are strongly type. So say we can say is a strongly type. That means we must have to associate a data type whenever we create a variable. Okay, but in Python and JavaScript, you just put a variable and its type is automatically determined by the runtime environment at the time of execution. Okay, but in C, you must have to associate a data type. So data type tells us about the type of data. In some languages, it also tells about the size associated with that particular data. And in some situations, the operation that you can perform on that particular data. Okay, so data type play an important role. So we know that machine knows only 0 and 1, but from a human perspective, the data is of variety. Data is of variety. Okay, sometimes we are dealing with numbers, sometimes with floating point values, sometimes with audio, sometimes video, sometimes with the strings, sequence of character. So every data is having a different memory and space requirement. Okay, and there is a variety of operation that different data types support. Okay, to categorize data in a proper way, we are having data type in C. Okay, so data type tells us about the type, in some languages the size, and the operation that we can perform a certain category of data. Okay, in C, we are having like a four primitive type. Let me just show you. So C language is rich in data types. So data type tells the type of data that you are going to store in memory. It gives the information to compiler that how much memory or the number of byte will be stored, will be used by the data. Okay. So sometimes it is a good programming practice to give the amount of memory uh, that we are going to require, that we are going to like use to run our application. Okay. So these data type like help your compiler a lot. Okay. So with the help of data type, a compiler can predict the size of the program, or we can say size of the program that is required uh, to execute it. Now look at this. So we can just divide all the data types into four different categories. We are having primary data type, then the user-defined data type, derived data type, and finally the entry data set, or we can say the void. Let me just give you a brief description of all this, a brief idea about this data type. Okay, so primary data types. So please check it out. So we are having four primary, or we can say character. Second is integer. The third one is float, and the fourth one is double. Character is basically used to deal with characters. Okay, so character is actually internally. So we can use character and integer interchangeably to hold the data. So character is basically used to represent a character symbol. Okay, but character are internally integer in C. Second, to hold numeric value, we are having integer. To hold floating point data, or we can say fractional values, we are having two different types. The first one is float, second one is double. Okay, if you want 6 place of accuracy, up to 6 decimal place accuracy, we can use float. If you want 18 to 19 decimal place accuracy, we can use double. Okay, and these long short are the modifiers that are basically used to increase and decrease the size and the range of a specific data type. Okay, so the four basic data type are character, integer, float, and double. Okay, now second category is of user-defined data type. Okay, so C support a feature of type definition that allow user to define an identifier that would represent an existing data type. Okay, so we can perform this operation with the help of type def. Okay, so sometimes when we create our own data type, the name of these data type are very lengthy. So if you want to assign a nickname to a user-defined data type, okay, so we can use type def for that purpose. After that, we are having enums. So enums, these are enumerators. Whenever you want to create a set of constants, so we can use enumerator for that purpose. We'll discuss enumerator in great detail in our upcoming session. Okay. Whenever you want to create a set of constants, we can use enumerator. So these are basically the user-defined data type. Okay, let me just give you an example of these of type def. When we discuss enumeration. Okay, so Please check it out. Suppose I'm having a structure. Okay. The name of structure is like employee of. Okay. So suppose the structure. Now, if I want to create a variable of this type, so what I have to do, I have to write struct dot struct. Then the name of a structure followed by the name of the variable. So look at this, it's very lengthy. Okay. So if I want to create like variable of this particular type multiple time in my application, so I have to repeat this lengthy name again and again. So what we can do, we can assign a nickname to this particular data type with the help of type def. So we just try it, type def, okay, and the data type name, and finally HREMP. Look at this. So HREMP is the nickname of this particular structure. Okay, so now we can use HREMP instead of this lengthy statement. Okay, if we want to create a like a object of a variable of type employee HR department, so now we start HREMP. Okay, that's it. Right. So this is actually a way to assign a nickname to your lengthy data types. Okay, this is how we can use that. The same way we are having enumerators. Enumerator are basically used to create a set of constants. Okay. So we'll discuss enumerators in further detail. So these are like basically the user defined data. Okay. After user defined data type, the third category is of a derived data type. So data type that we can create from existing data type, like arrays. Okay. So arrays are basically a group of similar type of data element. So whenever you want to create a group of object as a single entity, we can use array. In the same way, we are having function. Okay, so functions are nothing. These are the set of statement, okay, that are stored in a specific memory address. If you want to like access the location of a function, so you can store its address inside a function pointer. Functions are a set of statements that perform a single-threaded operations. After that, structures. So whenever you want to create your own data type which is not provided by your programming language, we can use structure for that purpose. The fourth is pointers. So pointer, these are like special types that can hold the address associated with another variable or pointer. Okay. So these are actually derived data types. Fourth category is empty data set, that is void. Okay, so void is the important one. Can you please use void? Where you have used void in C application. Yeah, we can use void to specify the different type of function. In the same way, we can use void to specify that the function is a function I cannot access a value. Okay. In the same way, we can use function for dynamic memory allocation. So if we create a void pointer, so you know that a void pointer can hold the address of any type of variable inside it. Okay. So void like play an important role in C. Okay. So the C compiler support an empty data set, which is mainly described in function. The void is an empty data set. So the type void is often used for declaring function, returning pointer that can point to any type of data. So just let me show you one small example of in which areas we can use void. So please check it out. Okay. And now suppose I'm in a function. Okay. Name greet message. Here I'll print a statement. Fine. We can just provide a gas start p. Okay. Hello. And followed by the name of look at this. So look at this. This function is just accepting a string and printing that string as output. Okay. Now this function is not returning anything to its calling environment. What we can do, we can just put a void. Okay. So this word signifies that this function accepts a vector string, vector pointer as argument, and return nothing to its calling environment. Okay. Now I can call this method message in this way. Fine. So the return type of a function to designate that this function doesn't return any response to its calling environment. With the calling environment, main is the calling environment, which is calling this greet message from line number 9. To save this code. Okay, so hello and change. So we are getting a proper output. Okay. Now, let me show you one more thing. Now, and this function doesn't have a argument associated with it. Now, suppose if I call this function with the value 10, can you please tell me what the output is? This function with value 10. What will the output in this case? Check out this code one more time. Did error? Okay. So let me compile this code for you all. Okay. Look at this. This function doesn't accept any argument, and during the time of function calling, I'm testing a value. Okay. Let me compile this code. Okay. It's compiled successfully, and if I run this code, look at it's working. Okay. So this is the issue with the C. So if a function doesn't accept any argument, what we have to do, we have to put a void explicitly. Okay. And when you compile this code, it will show you a warning. Look at this. I have specified void. Void means this function doesn't accept any input from its calling environment. Now it's warning too many arguments. Okay. If you remove this void, now your compiler will not show you any kind of warning. Look at this. But when you specify void, it knows that this function is not accepting any kind of value. So now if I try to compile this code, okay, look at this. Okay, we are getting an issue. Too many other functions. Okay, if I try to run this, we are getting an okay. There's a kind of warning. Too many arguments. Okay. So that's why if a function is not accepting an argument, you have to explicitly specify void. Okay. If you not specify void, the compiler will not show you any kind of warning. Look at this. So there's another advantage of void. Okay. There is one more use of void. So void is basically having void pointers. So void pointers are the pointers that can hold the address of any type of variable. We haven't discussed pointer yet, but let me show you a small example. Now, again, integer a is equal to 10. Okay, let me create the variable char ch is equal to a. So if I write a void r, okay, so void pointer. All right, ptr is equal to %. Okay, ptr is equal to % of. I'll try to compile it. Okay. So there isn't any message in this code, so we'll not get any output. Please check it out here. PTR is of type void pointer. And what is the advantage of void pointer? Void pointer can like uh, hold the address of it in the environment. Now, if I try to print the value, first of all, %d statement after particular statement. So what I'm doing, I'm just holding the address of the data variable. Now, if I want to like print the value as this variable, so what I have to do? First of all, I have to typecast it in integer. Okay, typecast it in integer, and then I have to specify like ptr. Yeah, I have to like put a star symbol. Please check it out. Copy this one, and here I have to specify cat. And so let me compile this code. Okay, so look at this. So void pointer is the pointer that can hold a variable. So while accessing the value out of this pointer, we need to typecast it to appropriate time. So this is the only requirement that we have to like fulfill while printing the value associated with the void pointer. Okay. So void pointer is an important data type in C. Yeah, generic pointers, absolutely correct. Okay, fine. These are basically the data types. So let me just explore these data type a bit more. Okay, primitive type a bit more. Okay. Now we are going to discuss like the signed, unsigned, long and short briefly. Okay. So C provides us like a data type. Along with the data type, it provides us like some modifiers. Okay, these modifier can increase the size of a data type. Sometimes it increases the size. Sometimes it increases the range. Okay, for example, so please check it out. I'm having an integer type variable. Okay, none. Let me show you the size of this particular integer. Printf hd size of num. Okay, I just want to like check the size of this particular number. So size size of num is equal to. So save it if I compile it. Okay. So look at this. In my machine, the size of integer is of 4 byte. Okay. Now, if I want to decrease the size of this integer, okay, suppose I just want to store a small and numeric value. Okay. to store a small numerical. Suppose I want to store like 15 inside this number. Okay. So if I'll create a variable of type integer, by default, this variable will acquire 4 byte of memory. Okay. But I'm going to hold a small, like a numeric value, which can easily accommodate in 2 byte or in 1 byte. So what I can do, I can just decrease the size of this particular data type just by applying a short in front of this number. Okay. So just by applying short in front of this number, so now your num will acquire only 2 byte of memory. Look at this. Fine. So short is actually size modifier. Okay. If you want to decrease the size associated with a specific data type variable, so we can use short. Okay. Now, suppose if I just want to hold a big numeric value, okay, what I can do, I can just put long. Okay, in Dev C++, int is by default long int. Okay, so the size of long int is 4. We check it out. It will still get 4 because by default int is a long int in Dev C++. If I want to further increase the size of this particular variable, what I can do, I can put one more long. Okay, please check out the size. Okay, now its size is 8. So long int is the maximum size. So it's the 8 byte. That means you can represent 2 to the power of like n minus 1 different values. Okay, 2 to the power of n minus 1 different values with the help of long int. Okay, so this is how we can use long and short to increase and decrease the size of a data type according to our requirement. Okay. In the same way, we are having 2 more modifier. The first one is like signed and unsigned. Okay. Signed and unsigned are the range modifier. Let me show you. Let me show you example with the help of a character variable. So can you please tell me what is the size of character in C? Is 1 byte. Can you please tell me why the size of character is 1 byte in C? Why it is 1 byte? Because we are having less than 255 characters. Because range is not 26, we are having only we are having less than 256 character in C because C is English language based. Okay, that's why we are having only few characters in C. So to represent those many characters, 1 byte is sufficient. But if we talk about like a latest programming language like Java, Python, and C#, so these languages are multilingual. Okay, so we are having like English, Hebrew, German, Hindi, and different type of characters. So to represent those many characters, 1 byte is not sufficient. So in all these modern programming language, we are having a 2 byte character, that is actually called Unicode. Fine, absolutely correct. So in C, 256, I think 1 byte is sufficient to represent 256 different characters. That's why the size of characters 1 byte in C. Fine. So okay, but there is one more important point that we need to note. In C and C++, character is both signed and unsigned. Okay, but in all the modern programming language like in Java, character is signed. Okay, what does actually means this signed and unsigned? So if a data type is signed, so that data type can represent both positive and negative value. Okay. If it is unsigned, so it can represent like only positive value inside it. Okay. Suppose I'm having a character char ch, and we know that the size of character is of 1 byte. Let me show you. Percentage C. Oh, sorry. Percentage T, comma size of ch. Okay. Size of char. But I'm just using the size of operator. Okay. The size of char is equal to 1. And now, so size of char, it is equivalent to 1. Okay. That means it is equivalent to 8 bits, and we can like represent 256 different values with the help of 1 byte. Okay, with the help of 1 byte. So it is actually 8, and we can just write 2 to the power of 8 different values. Okay, the size of characters of 1 byte, so we can just represent 2 to the power 8 different like characters with the help of 1 byte. So 2 to the power 8 is equivalent to like 256. Okay, we can represent numeric value like between 0 to 255. So 0 is the minimum range and 255 is the maximum range of a unsigned char. Okay, but if I'll use a signed char, and in signed char we can like represent both positive and negative value at once. Okay, so when we are dealing with signed char, we can like only use 7 bit to represent the data and 1 bit to represent the sign of that particular number. That's why when we are dealing with signed char, so the range is just half. Right? So we can just represent like 128 values in negative section and 128 values in positive section. Okay. So the range of a signed char is from minus 128 negative side to 127 the positive side. Okay. By default, when we never specify signed or unsigned, so the char is by default signed. Okay. Now, what I do if I try to assign like a numeric value, like a 23. Okay. So 23 is within the range of a signed char. So let me do one thing. I specify the range. So if a char is signed, its range is from minus 128 to 127. 128 from negative to 127. If it is unsigned, then range of the negative side will be included in the range of the positive side. If char range, in that case is from 0 to 255. So these are the characters that can be represented with the help of char in C. Okay, suppose if I write ch is equal to 23, and if I try to print f Okay, and here look at this. Here I'm using %d format specifier. Okay, so character is actually internally a number in C. So if I'll specify ch over here, please check it out. Fine. So what I'm doing, I'm just trying to print the code point. Okay, so it is actually a numeric value. So the 23 will be the output in this case. Let me compile this code. Yes. So we're getting 23. Okay, so now it is signed char. Let me change the value of this particular variable. Now I'm assigning a value beyond the range. So let me make it 127. So 127, it is signed char. Okay, so the maximum limit of positive side of a signed char is 127. If I save it and if I try to run this code, please check it out. Okay, 127. It is within the range. That's why we are getting the proper value. Now, if I'll increase its limit beyond the range, so look at this. So a signed char cannot hold 128 in it. Fine. So the range is the value is beyond the boundary of the acceptance. Fine. So still, I'm just trying to assign a value beyond the range, and if I try to print the value of ch, what will happen in this case? So look at this. We don't have any value after 127. So when we'll assign a 122 character, it will just move to the lowest value of this particular range. Beyond 127, we don't have any value. So what will happen in this case? It will pick the lowest value of this particular range. So the output will be minus 128. So here we are getting a cycle. Okay. Now if I'll increase the value with 129, so now it will start moving towards the 0. So the value we'll get is minus 127. So it is rotating within its range. So now C is trying to accommodate this value within this range itself. Fine, 127. Look at this. Fine. If I'll mention 256, save this one and run this code. Okay, we are getting 0 because it is like a complete this whole cycle. That's why we are getting 0. So this is actually the case when we try to like assign a value beyond the boundary. Okay. So this procedure is followed by all the data types in all the programming language. We try to assign a value beyond the range, so that particular environment try to accommodate that value within the given range. That's why we get different type of value. Now, look at this. Here I would just want to store like a 245. Okay, so 245 is within the range of character. Okay, but it is signed char. That's why signed char cannot accommodate 245 inside it. So what we can do in front of this signed char, I'll specify unsigned. Please check it out. So this value is beyond the range of signed char, so we'll get a different value. Okay, so what is happening? Your C is trying to accommodate this value within this particular range. Now, this value can be easily accommodated inside a unsigned char. Or it is unsigned. Sorry, it is unsigned. This unsigned range. So this particular value can be easily accommodated inside the unsigned range. So what we can do, we can put unsigned in the front of this particular character. So now its range will be increased from 0 to 255. So now you can accommodate this value within this particular range. Okay, but if I'll make it assigned, we cannot hold this much amount of value inside a signed char. So if you want to increase the range of a variable, we can look at this. Still, we are using 1 byte. Okay, but this 1 byte can hold a bigger value inside it. So this is actually advantage of unsigned. Okay, so we can, sorry. So we can hold like a large amount of value within the same memory area. This is actually advantage of this signed and unsigned. Signed and unsigned are range modifier, and long and short are size modifier. Okay, in the same way, we are having two more data type, like let me show you one more thing. This situation is also in case of integer. If I create integer variable, please check it out. If I write int like num, and it is of type short. Now this variable can hold maximum, I think 32767 inside it. This is the maximum limit of a signed integer, signed 2-byte integer. Seven six seven. Okay, if I'll increase its value by 1, now this value is beyond the like a range of a short signed int, so it will move to the lowest value of the specific range, -2768. Okay, but this value can easily be accommodated in unsigned int. So what we are doing, we are using 2-byte. Still, we are using 2-byte of memory, and we can hold a bigger numeric value inside it. So we can like properly optimize our memory with the help of signed and unsigned. Let me. Now we are having like a one more value. If I'll write 65535, okay. I think this is the maximum limit of a 2-byte short int. Let me check it. 65535. If I'll increase this value, now it is beyond the range of unsigned short int. Now we are getting 0. So it is moving to its own range. So now in this situation, what we have to do, we have to make it long. Fine. So this is how we can like adjust our memory. Just a minute. Yeah, please turn off your mic. Thank you so much, Neha. Okay, so this is how we can like customize the size of the memory that we required during the time of program writing. So this is how we can use a data type to optimize our memory in a proper way. Okay, so signed, unsigned, long and short. Okay, now if you just want to work with fractional values, we are having two more data types. The first one is float. Okay. The numeric value is it's 1 point. Where I'm having a floating point value, and let me print it. Percentage F, okay, or like float. Fine. And here I'll specify FLT. So to represent fractional values, we are having floating point. just want to display data up to 20 decimal places. So we have to specify 0.20. Okay. To display numbers up to 20 decimal places. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 19. Let me increase one more value, that is. To check out the accuracy, okay. So we are using float. The float is actually having 5 to 6 place of accuracy. Okay, so look at this. So 1, 2, 3, 4, 5, 6. After that, we are getting some round of value. Okay, now I'll make it double. Oh, sorry. For higher accuracy. And I think for double, we are having capital small f. Let me check it once. I haven't used a proper format specifier. Let me check it. Check it out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 1, 2, 3, 4, 5. Okay. So we are having like a hard decimal place accuracy. So 1, 2, 5, 7, 8, 9, 0, 1, 2, 3, 4, 5, 6, 7. Okay. So please check it out. So if you want higher accuracy after decimal places, use double. So double is look at this, how much decimal place accuracy we are having: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 14, and 15. Okay. So 15 place of accuracy. In case of float, only 5 place of accuracy, 5 to 6 place of accuracy. So this is how we can use float and double in C. So these are the 4 basic data type. So if you want, you can just take snapshot of these PPTs. So this PPT is actually look at this. So here we are having size. So this size just matter from platform to platform. Okay, if you're using a 64-bit machine, then the size of integer will be different in that environment. If you're using a 32-bit machine, then the size of integer will be different. Okay, so those charts just belong to dev C++. Okay, so the size of integer is of does this chart belong to Turbo C? But the size of integer is of 2 bytes. Please check it out. And this is the range. So it's 2 to the power of n minus 1 minus 1 minus 2 to the power of n. So you can easily compute the range with this formula. If you are dealing with a signed bit integer, the range will be 2 to the power of 16 minus 1 to minus 1. Right? A brief description of the data types. So data types tells us about the type of data, the size of data, and the operations we can perform on a specific type of data. Okay. Fine. Okay, so after data type, the next topic that we are going to cover is operators. Okay. So as you all know that operator are the special symbols to perform some kind of arithmetic and logical manipulations. So we are having a variety of operator in C. So this operator can be divided into like 3 different category on behalf of number of operators. We are having unary operator, binary operator, and ternary operator. Okay. And These are the operator categories on behalf of the behavior. So we are having arithmetic operators, then the relational operators, logical operator, assignment, increment, decrement, conditional operator, bitwise operator, special operator. Okay. So let me show you some of the operators that we can use in C. So these are the operators that performs some kind of arithmetic and logical manipulation. So I'll just start with like the first category, which is the most common category, the arithmetic operators. Okay. So in C, we are having like 5 different arithmetic operators. So the 5 operators are the plus, minus, multiplication, division, and modulus. As you all know that this is for these all are like binary operators. When we are dealing with arithmetic operator, these all are binary operators. Here we are having plus for addition, for subtraction, for multiplication, for division. Okay, so whenever we perform division, we'll get two different data. First of all, we'll get question and reminder. So if you're interested in question, use slash. If you're interested in reminder, use mod. Okay. So all the operators are like very simple, but you have to take care while performing operation, especially with these two operators. Just a minute. Please take care for mics. So rest of the operator plus not to multiply doesn't have any loophole associated with it, but you have to be very careful while dealing with the slash and modulus operator. Okay, because these two operators may lead your program to abnormal termination. Let me show you what is the issue with this operator. So if I create two numeric variables like int or just a minute, let me print a simple statement like result is equal to and percentage D, and here I'm trying to perform division between two numeric values. Just a minute. Sorry. So divide by 2. Please check it out. Fine. So here what I'm doing, I'm just trying to retrieve the quotient of this expression. So if I run this code, will not get any issues. Please check it out. So if I'll compile this one. Okay, so we are getting appropriate output, that is fine. But if I'll try to like, let me put one more statement. It's operator operator. Please check it out. So operator demos. Okay. So if I'll save this code, if I run it, so we'll get the data as per our requirement. Let me compile this one. Get this. Find operator demo, result is an end of code. Now what I'll do, if I'll just put a 0. So this issue is only with the division modulus operator. Okay. So look at this here. I'm trying to divide this value with 0. So this expression result infinity. And we don't have such amount of memory to hold an infinity value. That's why what will happen in this case, this program will terminate abnormally. So please check it out. This is neither a syntax error nor a semantic error. Okay, so this type of issue is beyond the limit of your compiler. Compiler will successfully compile your code, but at runtime, a program like fail. Okay, it terminates abnormally. So please check it out. Here we are getting an exception. We are using a new compiler. That's why this compiler is showing us a warning. That's not an error. But if I run this code, look at this, only operator demo, and look at this. So at this particular point, we are getting exception. So So what happened in this case? A program terminate abnormally. Okay, so whatever we have like put after this particular statement will not be executed, will not be evaluated. This is abnormal termination. Same issue is with the modulus operator. Fine. So at this particular point, we are getting exception. So program terminate abnormally, and whatever you put after this particular line will not be evaluated. So please check it out. So we are not getting end of code. Why? Because the program terminate abnormally at this particular point. Okay. So rest of the operator are very good, very innocent, but you have to be careful while working with modulus and this division operator. Okay. Now this is a like how you can work with the arithmetic operator. Okay. So after arithmetic, the next category is of increment and decrement operator. Okay. Increment and decrement operator are basically used to increase or decrease the value of a variable, and you can use this operator to jump to forward or backward in your memory location. Okay, suppose a pointer is pointing to a memory. If you want to move to a next memory location or the previous memory location, you can use this increment and decrement operator for that purpose. Okay. Now let me just show you a small example of increment and decrement operator. So there are two types of increment and decrement operators. So we are having pre and post, as you all know that. So operator, pre and post. Pre-increment, let me show example, and pre-decrement. Post, decrement, post. You can apply this increment and decrement operator only on variables. So x plus plus of x, that means first of all we have to increase the value associated with the x, and then we have to use that, consume that value. Okay. In second case, in the next case, first of all we have to consume the value of the variable in expression, then we have to increase the value of that particular variable. In case of minus x, first we have to decrease the value of x by 1, then we have to consume its value in the expression. In case of x minus minus, first of all, we'll consume the value of x, then we'll decrease. First of all, we'll consume the value of x in our expression, then we'll decrease its value by 1. Okay. So pre and post. Now, let me show a small example. So suppose now I'm having a variable or like int num of equal to 100. Okay. What I'm doing, I'm just writing like num plus plus. Okay. Or let me put the statement inside a printf function. Printf percentage %t, comma, num plus plus. Okay. Afterwards, what I'm doing, I'm printing the value of this num one more time. So can you please write the output in this case? Just a simple expression. So that you already know how to work with increment and decrement operators. Please check out the code one more time. And please tell me the output. And I'm using post increment. Absolutely correct. First of all, 100 followed by 101. Absolutely correct. Okay. And now, if I just put this plus plus just before, now what is the output in this case? Absolutely correct. We'll get 101 in both the cases. Fine. This is actually behavior of your increment. If I'll look at this, if I'll put a minus minus of num, so first of all, we have to decrease the value of num by 1. Then we have to consume it. So the output will be 99 and followed by 99 again. Okay, and if I'll put post decrement, output will be 100. First of all, the value of this variable will be using expression. Then it is decremented. Okay, let me save this one. 399. Okay, this is the behavior of plus plus and minus operator. Okay, now let me show you one more example. So let me comment this out for this one. I've commented the statement, okay, and here I'm specifying like minus of 100. Okay, just give me a moment. Let me copy this code. I'll copy this code in one more ID. So I'm just using one more ID, okay, because some reason. So inside C drive, view, oh, sorry. Okay, please check out this code. Mention. Can you please guess the output in this case? Any other? Okay. Two errors. Two errors. What are the two errors here? Just one. None. Second. None. Absolutely correct. Okay. So here we are having an issue. So we don't have any variable for now. As I told you earlier that this operator is applicable only on the variables. Right? So if I try to run this code, let's say we are getting L value required issue. Right? So we cannot apply increment and decrement operator on the literals. It's a literal. Right? So you can apply this operator on the variables. Okay. Now, if I'll make a small change over here, look at this. What I'm doing, I'll write like num minus 9. Okay. And look at what I'm doing. I'm just performing nesting of this operator. Right? I'm performing nesting of this operator. Okay. So what will the output in this case? Error. Absolutely correct. Because the inner function will return as a numeric literal, and we cannot perform operation on that literal as well. Okay. This is the issue with this increment operator. Just remember one thing: nesting of this operator is not possible, and you cannot perform increment decrement operator on the literals. Now, there is one more operator that we are going to use in this code as the like comma operator. Fine. What I'm doing, I'm trying to write a simple code and as a variable, I'm trying to assign a value. Okay, please check it out. These are some loopholes that I'm discussing with you all. Here I'm doing, I'm trying to print operation. Don't try to run this code. Huh? It's a very simple statement. What I've done, I'm just using some operator. Please check out the statement. I'm having 1, 2, 3, 4 different operators in this code. So what I'm doing, I'm just trying to assign a value, and then I'm trying to print the value of this particular number. Okay. So please guess the output in this case. So these are the normal operators that we use on regular basis. Yeah, actually, what is the issue with this code? Yeah, Shoaib, please check it out. Please give your response. I'm checking whether you are attending session or not. I just want response from all of you. Please check it out and please give me an answer. What will the output of this particular statement? Yeah, Praveen, what is the issue with this code? Why we are getting error? Anyone can please explain what is the issue with this particular code?
We can provide only one value for one variable in the initialization. If you write 2 or more values in one initialization, it can display error.
What is the issue with this particular statement? What is the reason that we cannot specify more than one value to a variable initialization?
In priority table, it is having is having the highest priority.
So what is happening in this case? Look at this. Here, what I'm doing, num1 is equal to 10. I'm trying to assign this 10 as a value to this num, and I'm treating this 20 as it's identifier. Look at this. If I put ABC, what is happening in this case? ABC is a valid identifier. Okay. But if I look at this, here what I'm doing, I'm just putting like 4 variable and I'm initializing num by 10. Okay. But if I'll put like 20 over here, we are violating the rule of an identifier. Getting my point? Identifier never begin with the digits. This is the issue with this code. Right. So your compile is treating this value as an identifier. Identifier never begin with the digits. That's the issue. But if I'll put like A, B, C, now we are not violating the rule of an identifier. And precedence is the another case. Getting the idea? We are actually violating the rule of an identifier. That's the reason. Fine. Okay. Absolutely correct. So if you'll know this answer, and definitely you'll know this answer as well. This is for the student who don't know the behavior of this comma operator. Okay. So now what I'll do, I'll just put a semicolon and I'll write num. Okay. Now, what is the output in this case? Now we don't have, look at this. Now we are not declaring these variables. So these are no more identifiers. These are the values. Absolutely correct. Why? The precedence of this equal to operator is greater than the comma. That's why we will get 10. But if I'll wrap this these values within parentheses, okay, we have increased the precedence of like a comma. The output will be. Please tell me the output. 40 in this case, absolutely correct. Action. Please check it out. Right. So this statement follows a specific chart. Okay. So we are having an operator precedence as to do the chart in C. So at the top of the hierarchy, we are having special operators. Where we are having this square bracket, parentheses, dot, and arrow. Right. So these are the operator having higher precedence in C. Then we are having unary operator. Unary operator, we are having unary plus, unary minus, tilde, not operator. Then we are having increment and decrement operator. Okay. Followed by size of operator and typecast operator. Having that pointer and the address of operator in this preference in this sequence. After special, we are having unary, then assignment operator. Oh, sorry, arithmetic operator. So the preference of multiplication, division, and modulus is higher than that of addition and subtraction. Here, left shift and right shift. So that we are having comparison operator, or we can say the relational operator. Fine. Here we are having less than, greater than, less than equal to, greater than equal to, followed by equality and not equality operator. So that is the bitwise operator. Bitwise, the precedence is of bitwise and, followed by bitwise XOR and the bitwise OR. Logical operator. Okay. This is of logical, not actually. Fine. Followed by logical and logical. Then ternary operator. Ternary, question mark and colon. Then assignment operator. Okay. Equal to, plus equal to, minus equal to, divide equal to, multiply equal to, left shift equal to, right shift. A lot of like a assignment operator. So actually operator precedence. Yeah, so please check out this statement. So what we are doing in this case, so the precedence of equal to, look at this. If I'll write a statement in this way, the precedence of equal to is greater than comma. Okay. Please check it out here. We are having equal to and we are having comma. We are equal to is having the higher precedence than comma. First of all, the value is assigned to the number. Okay. That's why we are getting 10 as output. But when we wrap these values between parentheses, so we are increasing the precedence of comma over equal to. Okay. And the like associativity of comma is from left to right, so the last value will be returned and get stored inside num. So this all is happening due to this operator precedence chart. When we are having like a different operator of different power in an expression, then in that case we have to use operator precedence. Okay. When we are having multiple operator of same power within an expression, then we have to use associativity. Okay. So unary, only three categories are from right to left associated. The first one is unary. I think the second one is ternary operator. So it is right to left associative. And the assignment operator is right to left associative. And rest of the other categories are from left to right associative. Yeah, so the associativity of special This automatic shift comparison is from left to right. The associativity of like a unary, ternary, and this assignment operator is from right to left. So just remember this chart. It's very important. So just try to memorize this chart. It will help you a lot while solving expression in C. The special unary, automatic, shift, comparison, bitwise, logical, ternary, assignment, and comma operator. Okay. Let me show you like one example of associativity. So suppose I'm having some variables. Okay. What I'm doing, I'm just initializing all these variables by 10. Fine. So A is equal to B. What I'm doing, I'm just look at this. So the equal to operator is from right to left associative. So what I'm doing is from right to left associative. So I'm trying to assign this value to D. The value of D will initialize the value of C. Value of C will initialize D, and so on. Fine. Now what I'm doing, I'm just performing some operations. A plus is equal to B minus is equal to C divide is equal to D plus equal. What I'm doing, I'm just trying to print the value of all these variables, percentage T, percentage T, percentage T, value of A, comma B, comma C, comma D. Here we are having right to left associativity, right? So please try to compute these operations. So look at this, it is right to left associative. This expression will be solved from right to left. Adjustment, A plus equal to minus adjustment. We are having an issue. Divide is equal to and multiply. Please check it out. Please write down your solution in the chat window. Right to left associative, okay? Let me do one thing. Let me increase this value. Okay. Make it, no worries. It will return a fraction. Let me increase it by like no worries. No worries. Is equal to 20. 10 into 2 is equal to 20. Fine. Here we are using a division operation. Fine. So this output, like designate that this expression is solving from right to left. So it is a right to left associative. So look at this here. I'm using assignment operator only. Fine. And the associativity of assignment operator is from right to left. That's why we are getting this type of output. Okay. So associativity and precedence both are important. So we have to use precedence when we are having operator of different powers within expression. We have to use associativity when we are having multiple operator from of same power within expression. Okay. So today we have discussed some of the basic operators. Tomorrow we'll cover flow control. After flow control, we'll work with the functions. Fine. Thank you so much. That's all for the day. We'll be tomorrow at the same time. Till then, take care. You all can leave the session for now. Welcome. You're welcome, all of you.